Welcome to the tutorial room. Select a topic, Chapter 7, Real Numbers. Section 7.6, Exponents. In this section, we'll teach you about exponents. Many algebraic expressions involve exponents. In fact, exponents are used extensively in a number of fields, including industry, science, mathematics, medicine, and engineering. Exponents are a shorthand way to show how many times a number is multiplied by itself. For example, when we multiply a number times itself, we can use exponents to show the repeated multiplications. For example, we can write 6 times 6 as 6 raised to the power 2, or 6 squared. We can write 2 times 2 times 2 as 2 raised to the power 3, or 2 cubed. And we can write 3 times itself 4 times as 3 raised to the power 4, or 3 to the fourth. In general, the number a raised to the power m means a times itself m times. In an expression with exponents, a is called the base, and m is called the exponent, or the power. A number of rules of exponents follow from this definition. For all the rules shown below, think of x and y as any real numbers, except for 0 in the cases noted. Also, for the scope of this course, the letters m and n must represent integers. Rules of 1. 1 raised to any power equals 1. Any number raised to the power of 1 equals itself. 1 raised to the power of m equals 1. X raised to the power 1 equals x. Product rule. To multiply two powers with the same base, add the exponents. X raised to the power of m times x raised to the power n equals x raised to the power m plus n. 1 raised to the power of 4 equals 1 times 1 times 1 times 1 equals 1. 3 raised to the first power equals 3. 4 squared times 4 cubed equals 4 times 4 times 4 times 4 times 4. 4 raised to the power 2 plus 3 equals 4 raised to the power of 5. When we multiply 4 squared times 4 cubed, the result is 4 times itself 5 times. The product rule tells us to simply add the exponents when multiplying two powers with the same base. Power rule. To multiply a power raised to a power, multiply the exponents. X raised to the power m raised to the power n equals x raised to the power m times n. Power of a product rule. To multiply a product raised to a power, raise each factor in the product to the power. X times y raised to the power m equals x raised to the power m times y raised to the power m. 4 cubed squared equals 4 times 4 times 4 times 4 times 4 times 4. 4 raised to the power 3 times 2 equals 4 raised to the power of 6. When we multiply 4 cubed raised to the power of 2, the result is 4 cubed times 4 cubed. The power rule tells us to simply multiply the 4 times 2 cubed equals 4 times 2 times 4 times 2 times 4 times 2. 4 cubed times 2 cubed equals 4 times 4 times 4 times 2 times 2 times 2. To multiply 4 times 2 cubed, we multiply 4 times 2 by itself 3 times. If we rearrange the terms using the commutative and associative properties of multiplication, the result is 4 cubed times 2 cubed. The power of a product rule tells us that we can simply raise each factor in the product to the power. Power of a quotient rule. To divide a quotient raised to a power, raise both the dividend and divisor to the power. X divided by y raised to the power m equals x raised to the power m divided by y raised to the power m, where y is not equal to 0. Quotient rule. To divide two powers with the same base, subtract the exponents. X raised to the power m divided by x raised to the power n equals x raised to the power m minus n, where x is not equal to 0. Zero power rule. Any non-zero number raised to the power of 0 equals 1. X raised to the power of 0 equals 1, where x is not equal to 0. Negative integer power rule. Any non-zero number raised to a negative power equals its reciprocal raised to the opposite positive power. X raised to the power negative n equals 1 divided by x raised to the power n, where x is not equal to 0. 1 divided by x raised to the power negative n equals x raised to the power n, where x is not equal to 0. X over y raised to the power negative m equals y raised to the power m over x raised to the power m, where x is not equal to 0, y is not equal to 0. 4 raised to the power negative 2 equals 1 over 4 squared equals 1 over 16. The negative integer power rule tells us any non-zero number raised to a negative power equals its reciprocal raised to the opposite positive power. So 4 raised to the power of negative 2 equals 1 over 4 squared. Watch out, here are some common mistakes that students make when working with exponents. The exponent next to a number only applies to that number, unless parentheses in the equation indicate otherwise. Negative 4 squared is not equal to negative 4 squared. Negative 4 times 4 is not equal to negative 4 times negative 4. Negative 16 is not equal to 16. The product rule, x raised to the power m times x raised to the power n equals x raised to the power m plus n, only applies to expressions with the same base. 4 squared times 2 cubed is not equal to 8 raised to the power 2 plus 3. 4 times 4 times 2 times 2 times 2 is not equal to 8 raised to the power 5. 128 is not equal to 32,768. The product rule, x raised to the power m times x raised to the power n equals x raised to the power m plus n, applies to the product, not the sum of two numbers. 2 squared plus 2 cubed is not equal to 2 raised to the power 2 plus 3. 2 times 2 plus 2 times 2 times 2 is not equal to 2 raised to the power of 5. 4 plus 8 is not equal to 2 times 2 times 2 times 2 times 2. 12 is not equal to 32. The power of a product rule. X times y raised to the power of m equals x raised to the power of m times y raised to the power of m applies to the product, not the sum of two numbers. 2 plus 3 squared is not equal to 2 squared plus 3 squared. 5 squared is not equal to 2 times 2 plus 3 times 3. 5 times 5 is not equal to 4 plus 9. 25 is not equal to 13. Here, try these practices. Good job, you're right. Good job, you're right. Good job, you're right.